Hello, welcome back to Chapter 5, Section 1, Identifying Linear Functions. One more time, I'm doing the guided practice problems on page 300, page 9 in the PDF, and we're going to do problems 5, 6, 7, and 8. When we did this before, our graphs were vertical. Now tables, excuse me. Our tables are horizontal. That doesn't matter. What I need to find is my change in x and my change in y. And remember that Greek letter there, I know it looks like a triangle, that is the Greek letter delta. And in science and math, delta means change. And change is something very important we talk about in math and science. So let's find out what the change in x's are. To go from 5 to 4, it's going to go down 1. 4 to 3 also goes down 1. 3 to 2 also goes down 1. And 2 to 1. So my change in x is -1. And that is a constant change. This is also called the first difference, but that's not going to make much sense because you're probably going to ask, what about second, and third, and fourth differences? Those will come later. Let's figure out what the change in y is. To go from 0 to 2, I'm going to go up 2. 2 to 4 is up 2. To 6 is up 2. And from 6 to 8, I go up 2. So my change in y is plus 2. Since both of these are constant change, yes, this is a linear function. Let's look at problem number 6. 1 to 4, if I do 4 minus 1, that equals 3, plus 3. From 4 to 9, that's going to be plus 5. Now before you think, well, wait a second, that already means it's not constant change, I have to check both of them. From 9 to 16, sorry, didn't draw my arrow very well. From 9 to 16, that's going to be plus 7. And from 16 to 25, that's going to be plus 9. So far, my change in x, I don't have one. From 1 to 2, that's plus 1. That's plus 1. 3 to 4 is plus 1. And 4 to 5 is plus 1. My change in y is plus 1. Since I don't have constant change for both of them, this is not a linear function. Now this is a perfect example of where I would tell students, don't make it too hard, because they'll say, well, wait a second, I see 3, 5, 7, 9, that's a pattern. We're not saying that you have to look for a pattern. It's that these changes have to be the same number, okay? And there's one thing, the reason why I said let's wait until we find out the change in y, because there's one thing that might be in there, but I think you're not going to see it on the test. Sometimes if they both go up by the same amount, so like if this one went up 3, this went up 1, and if this went up, say, 6, and this one went up 2, 3 over 1 and 6 over 2 would be the same. Okay, it just means that you're skipping something, you're hiding it. So that, I kind of think that that's a little tricky, so I'm not going to put that in anything that you have to do. I don't think it's in any of the homework assignments, but if it is, ask a question about it in the discussion. We are going to do these type of things though. And if you remember in the previous chapter, we call this a set of ordered pairs, which is fine. You don't have to change it to a table, but you can change it to a table easily. I'm going to do that for the first one. So I'm going to make my table of x and y. So my first one is 0, 5, 0, 5, -2, 3, -4, 1, -6, -1, and -8, -3. Extend that out just a little bit more and make it pretty. Okay, so I can convert to a table. 0 to -2 goes down 2. That still goes down 2. all of these are decreasing by 2. So my change in x is negative 2. 5 to 3 is negative 2. 3 to 1 is negative 2. 1 to negative 1 is negative 2. And negative 1 and negative 3 is negative 2. So my change in y is negative 2. Don't worry about the fact that both of these are the same. They don't have to be the same. It's all of these have to be the same, and all of these have to be the same. They just don't have to be the same to each other. Okay? This is yes. It is a linear function. I have a constant change in y and a constant change in x. For number 8, I'm going to show you a way to do it without writing the table. But again, you can make the table. I'm just going to look at the x's. 2, negative 1, negative 4, negative 7, negative 10. To go from 2 to negative 1, that's down 3. To go from negative 1 to negative 4, that's also down 3. To go from negative 4 to negative 7, that's also down 3. And to go from negative 7 to negative 10, that's also down 3. So my change in x, because I was looking at the x values, is negative 3. Now for the y's, negative 2 to 0 is plus 2. 0 to 1 is plus 1. 1 to 3 is plus 2. And 3 to 6 is plus 3. See what I did? I just looked at the y values. So first I looked at the x values, then I looked at the y values. I do the same thing if I wrote in the table. There is no constant change in y. So this one is not linear. Okay, ask questions, rewatch the video, do what you can. We'll see you later.